All right. Hey guys, hope you're having a great day. This is a video going over some of the TR2 Gazebo integrations and how to get started with the TR2 how to get started with Gazebo using the TR2, however you want to say that. So this, I have the basic functionality for Gazebo finished. There's a lot more to Gazebo. There's a lot Gazebo has to offer. We will continue to improve the support and add more features. So this isn't 100% complete. A good example is there's not a lot of documentation on this. You pretty much just have this video. You have the source code. Good luck. But we will, in the months ahead, we will continue to add documentation, add more support, how to get started. This is valuable for current customers that have a TR2 because you can develop applications on the simulation and then port those over to the robot. And there's various reasons why that might save you some time. But then also for potential customers, this is a way for you to kind of try out the TR2 and kind of see what it's about. And also for people that are just interested. So, welcome everybody. No matter what your reason for being here, I hope this, I just want to help you out in any way. So this will give you a base point, a base reference point. Keep up with updates and things like that as we post them. Follow us on our social media. We'll be sure to update you guys there. And then of course, just post any questions, comments, or things like that if you have any problems or have any questions about this. So getting started. This assumes you have ROS installed. This assumes you have Gazebo installed. Won't get into how to do that there. We are using ROS Kinetic. And what you'll have to do, I'll have the link in the description. You have to clone our Git repository that's up on GitHub, the TR2_essentials library. So if you were to do that here, here I've gone into my ROS workstation, I've gone into the source folder, and we'll do git clone https://github.com/Slate Robotics/ TR2_essentials. So this will clone the repository. Now I already have the repository installed here, and so I don't need to do that again, but that's how you would do it for yourself. So once we have that, we can do ROS launch TR2_Gazebo and then TR2_empty.launch. So this launch file will fire up the controllers. It'll fire up the Gazebo simulation. It'll place the TR2 object in the center of the world, and there's no other object in the world, so that's why it's TR2_empty. There's one more thing though you have to consider with this launch file. There is a control parameter. By default, this launch file will fire up the trajectory controllers. There's also position controllers and effort controllers. I wish I could just fire them all up at the same time, but there are what is it called? Resource constraints or resource conflicts or something like that. That's the error that it throws. So I can't fire up everything because the arm trajectory controller needs to control all of the arm joints. But for our purposes, we're going to fire up the position controller because this is a little easier to demo and show some of the functionality. So fire that up. So as we've said, here's a TR2 right in the center of the world, just like that. And yeah, not much there. So what we can do now that that's open, we can do open up another tab. We can do ROS topic list. This will show all of the ROS topics that are available for both publishing and subscribing. If you want to, ROS topic echo TR2 state. This will publish all of the joint states very quickly. And then if you want to actually, let's say we want to move one of the joints, then what we'll do is we'll publish to TR2 joints, and then there are 5 joints in the arm. That's A0 through A4. So this is A0, A1, A2, A3, and A4. Let's say we'll do A1, control position, and this is a float 64 message type, and we'll do 0.8. That's 0.8 radians from the origin or home position. And then all we need to do if we want to control another joint, we just go in and change the joint name, change the joint angle. We can do 2. So that kind of stuff. So that's how you get started moving some of the joints by publishing to the Robotics. That's all pretty cool stuff. There is a so you can control it over, using the command line interface. You can control it by publishing to the Robotics. I have already built out a library called TR2_sim. And this has the same interface. So there's 2 TR2 Python libraries, or Python, classes. One is in this TR2_sim file, and the other one is in just the tr2.py file. So these both have the same interface. They both have state, drive, release. You'll find that in both of the state, drive, release. You'll find that in both the files. One is controlling actual hardware. The other one is just basically publishing to the Robotics for purposes of controlling the simulation, hence the name, right? So the idea is you can write the same program here in the simulation, and maybe we'll find a better way to do this in the future, but right now, I think it's pretty easy. If you want to take your program from simulation and try it on the actual robot, all you need to do is just import the TR2 class from the tr2.py file instead of the tr2_sim.py file. So this is how you control, at least for this video, the TR2 in simulation, and that gives you a little bit of an idea of how you're going to port over your same program into the actual TR2 hardware, which is pretty cool. I'll let you guys dig into the program, dig in some of the source code, and worry about that. All we need to talk about here really is that I've got an array of positions. This last this last item in each of the arrays are how long it sleeps for, and then it just sets those positions. So these are the joints A0 through A4, and then set those positions based on what we've got here. We're also doing tr2.drive. This controls the base. The first parameter is controlling the left wheel. The right parameter, or second parameter, is controlling the right wheel. So from the robot's perspective, so if we want to run this program, all we need to do is tr2, ROS launch, then tr2 py tr2 hello world _sim.launch, and that will fire up that program there. So as you can see, that's the first position. You'll also notice that the base is driving in circles, and it's the fourth position, and then finally the fifth position, just like that. So that was all. This simulation was controlled, again, by this code. So if you want to try it out for yourself, then basically you can, I would suggest creating a separate package and copying some of the code in the launch file from what you see here into that one. Then you can really play around and mess around with that. So one last thing I want to talk about before we wrap the video up is the camera. So we actually have a camera object placed on the robot's description, and I've done some integration so that it will publish that Gazebo. It basically publishes what the camera would see if there was a real camera there. So it's a simulated camera in Gazebo. Again, this is so that the simulated robot behaves very similarly to what you would see with the actual robots. So you can base some of your programs off of that. So let me demonstrate that just for a second. We can run ROS topic list there, and we can see that there is this camera ROS topic, and that's all here. So all of that data gets published, both the depth information and the RGB camera information all gets published there. So if we want to visualize that, we can do ROS launch TR2 description, and then TR2 underscore Zacro dot launch. This will fire up RViz with the TR2 being shown there. You can see that the states mirror each other. And if we want to see the camera, we just click add by topic and then camera there. So now you can see that what's being displayed here is the same as what the robot would see. Oops, let me try to center that. Just like that. So that's what the robot would see if there was actually a camera there. And we can run our program from last time, and we can see that they both match up, they both sync up. So again, this camera, this is just image data. This is just a video, and so this isn't actually simulation right here. This is just video output from the simulation itself. So that pretty much wraps everything up. I guess we can go ahead and close out of that here. Again, if you are interested, check it out. The link to the repository is in the description of this video. And yeah, we'll continue to improve. We'll continue to make this even better. There are some issues, some small things, some a little bit bigger that I would like to work on in the future. Just keep your eyes peeled for that. But for now, this gives you enough to really get in there, get started, start playing around, controlling the robot, and kind of getting a sense of what the TR2 is about. So thanks for watching. Comments in the down below, or post any questions or things like that to our website. That would be great. There's a question and answer section of our site, which would be helpful, because other people will also be able to see any problems you guys have and might help them out there too. So thanks for watching. We'll see you guys next time. Have a great day.